Our objective for today, I can simplify exponential expressions with fractional exponents. Read together, 1, 2, 3. I can simplify exponential expressions with fractional exponents. Read again, 1, 2, 3.
I can simplify
All right, so we're still on the same concept. You don't need a Fourier model, so don't write that down, right? Because we already know what exponential expressions are, right? Good. So we do have an essential question. We'll answer that at the end. It's what happens to an exponential expression that has a fractional exponent instead of an integer exponent? We'll address that towards the end. So we don't need a Fourier model. We know what they are. We do need steps. Copy these, please. Step 1, rewrite as a radical and factor the number completely. Step 2, identify the index of the radical to find the root. Step 3, raise to the power outside the parentheses. Step 4, simplify. Copy that. Okay, let me clarify some of the terminology used in here. Now, if you notice on the steps, there are certain terms that maybe this is the first time you hear in the math context. One of them, for example, radical. I'm not saying like I'm not like saying like, oh, this is radical, dude, or anything like that, right? What I'm saying is that this has a meaning. From now on, whenever you see the word radical, do this. Look up. Before, we used to know it as a square root. But that was for 7th grade and below. Now that we're in algebra, we're going to be looking at roots higher than 2. Okay? Index, I'll explain what that is. For example, let's say I gave you a radical like this, and I put a little number in front of it, such as this. From now on, you're going to start seeing numbers in front of it. That's what we call the index. Inside of the radical, it's going to have a number such as 27. And this number inside is called the radicand. Radicand. The number inside is called a radicand. What is the symbol called? The radical. What is the little number outside called? The index. Are we there? Now, how does this work? Let me show you how this works. The index tells me how many times I'm going to multiply a number times itself. How many times am I going to multiply it? 3 times to give me the radicand. What number times itself gives me 27 if I multiply it 3 times itself? Is it 1? No. 1 times 1 times 1? No. How about 2 times 2 times 2? No. How about 3 times 3 times 3? Yes. The simplification will be 3. This number is known as the root. The root. Now, in the past, you used to have problems that look like this. Square root of 16. And, of course, you wrote what? 4. Now, do you guys notice that this one doesn't have a number outside? Because this is the smallest radical that exists. And everybody knows that we multiply the number times itself how many times? 2. So we assume that we already identified that there's an invisible 2 there. Everybody understand? All right. So with that said, set that aside. Writing utensils down, I just want to review some prime numbers and composite. Prime numbers, what are they? Numbers that only have factors of 1 and themselves. 1 times 2 is 2. Is there any other pair of numbers that multiply to give me 2? No. 1 times 3 is 3. 1 times 5 is 5. 1 times 7 is 7. And 1 times 11 is 11, and I can continue going. The ones that are not prime are composite. For example, 4 is composite. Why? Because 1 times 4 is 4, or 2 times 2 is 4. 6 is composite because 1 times 6 is 6, or 2 times 3 is 6. 12 is composite. Why? Because 1 times 12, 2 times 6, 3 times 4. See that? They have more than one pair of factors. These you're going to have to remember throughout because we're going to be using those a lot. Here we go. Who remembers prime factorization? All of us? Yeah? Remember when you were in, I think, 4th grade, your teacher said, okay, kids, we're going to do a factor tree. And then they drew a little Christmas tree. Remember that? Okay, write this down. 12. We're not going to draw a tree, but what we're going to do is do a factor tree for this one, like this. And we're always going to start with a prime number, either 2, 3, 5, 7, or 11. One of those 5 has to be what we start with. What number factors evenly in there? 2? How about 3? Yeah, so we're going to start with the biggest one, which is 3. Circle the 3 because that's a prime number, and we're left with 4. 4 becomes 2 times 2. So my prime factors are 3 times 2 times 2. These are called prime factors because if we multiply them, it gives us the original number we started with. Yes? Okay, do this one by yourself. 20. Find me the prime factors, please. Go. All right, so you started with 5 times 4, is that correct? And then this is 2 times 2. So this is 5 times 2 times 2. And does that give us that? Yes. Are we there? All right. We want to keep that in mind because when we get to bigger numbers, we're going to have to do prime factorization. This is where I want to get to, though. On your paper, write this down. Example Q. We're going to be looking at fractional exponents. So let's start with x to the 1/2, x to the 1/3, x to the 1/4, x to the 1/5, dot, 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 x to the 1/23. I'm going to leave a space, writing utensils down. And here's where I want you to start thinking outside the box, because this is going to be pretty challenging, so I need you guys to really focus. Here it goes, writing utensils down. So now if you notice, we have a fractional exponent, yes? But guess what? We have already been working with this one. Let me show you what it looks like in the regular world. So the half exponent is actually a what? A square root. Therefore, let me show you how to rewrite these. This one is a radical, index of 3, and the radicand of x. Let me rewrite this one. Radical, what is the index? 4, and what is the radicand? X. Therefore, this one is what? Radical, what is the index? 5, and the radicand? X. And with that same idea, radical, what is the index? 23, and what is the radicand? X. Copy that, and I'll show you how that works. All right, let me show you with numbers how this looks. 8. No, let's do 9. 9 to the 1/2. 8 to the 1/3. 16 to the 1/4. All right? Writing utensils down, look up. Let me show you how this works. We said that the 1/2 is a what? Square root, right? So this becomes square root. What is the radicand? So what is square root of 9? 3. Look at this one. Radical, what is the index? 3. Radicand? 8. So how does this work? Well, the index tells me how many numbers, or how many times to multiply a number by itself. How many times? 3. 1, 2, 3. One number times itself 3 times gives me 8. 2. 2 times 2 times 2 is 8. Look at this one. This becomes radical, 4th index, and then it's 16. This says how many times, one number times itself 4 times give me 16. What is that number? Everyone? Also 2. 2 times 2, 4 times 2, 8 times 2, 16. As you're copying that, copy this next one and do this one by yourself. 125 to the 1/3. Go. Copy that. Go. Let's see. Who rewrote this like this? Radical third index, 125. Which means what number times itself 3 times give me 125? What was that number? 5. That is correct. So now, from this point forward, I want you to think about this. The first 5 prime are 2, 3, 5, 7, and 11, yes? So usually, most of the roots are going to fall into one of these. If it's not one of those, start by looking at the numbers in between. What number is missing here in between? 4. The next one is 6, 8, 9, and so on and so forth. Does that make sense? So first start looking through prime numbers. Therefore, copy this next one, please. Example 1A. 343 to the 1/3 power. If we rewrite that, what does it look like? This becomes what? Radical, index of 3. Radicand is 343. What does that mean? What number times itself 3 times? Give me that number, yes? So think about it. What are my first 5 prime? 2, 3, 5, 7, 11. Does any of those work? The 2, no. The 3, no. The 5, no. The 7? 7 times 7, 49. Times 7, 63. I got 6. 28 plus 6, that's 34. Therefore, this is 7. Copy this one. Example B. Yes?
I can inadvertently agree on any that you update a video game reference like that with example A.
Inadvertent what?
A video game reference.
Oh, okay, thank you. Copy B. It says 32 to the 1/5 plus 9 to the 1/2. Julian, how do I rewrite this one? 32 to the 1/5. What do I do?
All right. I know the thing, but a radical
Radical.
and outside 5.
5.
Inside 32.
32. That means a number times itself 5 times. What is that number, people?
2.
2. That is correct. Bring down the plus. Daniel, how do you rewrite this one?
Radical. And then inside is 9.
So we don't put the index, right?
And, yeah, no,
So what is square root of 9?
3.
So what is 2 plus 3? 5. Do you see what we're doing? Okay. Let's do one more. I want you to do C. Let's see how you do. See what I did there? No? Get it like C? Like C is 81 to the 1/4. You tell me what to write. Radical.
4.
Index of 4. And 81 of the radicand. 1 of them times itself. 4 times give me 81, everyone. 3. We got this, right? All right. I want to get to this next one. This is the last example. Look up to the screen. Don't copy this, just pay attention. You'll copy at the end. In the home plate, you're going to have stuff that looks something like this, but with a number. For example, 8 to the 2/3. You're saying, oh my goodness, Mr. Q. Now it has a number greater than 1 on the numerator. You guys see that? Will you be comfortable if we rewrite it like this? A to the 1/3. Do you know what this is?
Yeah.
Yeah? So what happens to this 2? We write it right next to it right here. See what I did? Isn't this the same as this? Yeah, because 2 times 1 is 2, and it's 2/3, right? So now check this out. Why did I need to rewrite it like this? Because I know what to do with this. This is radical, index of 3, and 8. Is that correct? Multiplication. And what is the exponent outside? 2. Therefore, what is cube root of 8? What number times itself 3 times give me 8? 2. What's outside of the parentheses to the second power? What is 2 to the second power? 4. Copy that. You're going to have a couple of them that look like this, so make sure you understand the process. So you need to rewrite it first and then go through the process like this. Okay, I'm going to do one more. You don't have to copy this one so that you can, as you finish that. 16 to the 3/4. Check this out. Let's see if you get this. We rewrite it as 16 1/4 times 3. Is that correct? 16 to the 1/4 becomes 4th root of 16. And then with the exponent of 3 outside, this is 2 to the 3rd power, and this is 8. Okay? Your home play for tonight is on page 35 from your book. We're now in the book now. All right? Page 35. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.